So the problem here is that on the TI, you do see that square root symbol. But what about the third root, or the fourth root, or the fifth root? Unlike the power exponent, say third, fourth, fifth, etc., which does have its key here, the raising to key, on the third root and beyond, well, we're going to have to access the math key. So what you need to do is, let's say you wanted to know the third root of 8. So you would press the math key, and you can see that you get all of these options here. Now they're numbered for convenience. So the number 1 says frac, the 2 says dec, this is fraction, decimal, the 3 means cube, the 4 means third root of, and the 5th one says x root of. Well, if you want the third root of 8, you would use that fourth function here, third root of. So press the 4 key. So you can see that the calculator back on the entry mode, it's giving you the third root of. And then you can just key in the 8 that we wanted. Again, no need to get out of it. We can just press enter. And we see the correct answer. Third root of 8 is 2. Now let's say the expression was a little bit more complicated. Like 5 minus the third root of 27. So you would do 5 minus. Now for the third root of 27, well, what you need to do is again math key. Third root is the fourth function, so press 4. And you see how the calculator will bring you back to the entry screen, and it's showing you the third root of. Now you press 27. Enter. And you get 2. Why? Because the third root of 27 is 3, and 5 minus 3 is equal to 2. Now, it's unlikely that you'll encounter roots that are above the third root on an ACT exam, but say you had one, you needed to find out, say, the third root of 100. How would you do that? The fourth root of 100, I'm sorry. The fourth root of 100. How do you enter that? You know how to enter the square root. It's right there. But that's not what we want. We know how to do the third root. It's doing the math for third root, but that's not what we want. So how do we input the fourth root of 100? Well, pressing the math key again, notice that the 5th line here, the 5, says x and a root. What this means is that you get to define the value of x. So if you want x to be 4, you're going to be able to specify that. If you wanted, say, the 7th root, you would then be able to specify it as well. So the 5th one is kind of a generic. It allows you to enter any root you want. Let's see how that's done. Press the 5, and you can see that now the TI is displaying a root symbol with the cursor blinking both outside, and then if I move with the arrow key, it'll blink inside. So I get to define, specify both of these numbers. It didn't happen on the other ones. On the other ones, the 3 was fixed, or the square wasn't even shown. But if I use that 5th function key on the math mode, the 5th one, I get to specify both. So the 4th, press 4. Now, of course, you now want to move away from there, because if I enter 100, it's going to be 4,100 as a root value, which is not what we want. So we need to navigate with the cursor keys. Now you're inside the root symbol. Press 100. No need to get out of it. If I'm done, I can just press enter. And this is the fourth root of 100. An irrational number, meaning a decimal that is never ending with non-repeating blocks. And we know that because any imperfect root will always be an irrational answer. Will always give you irrational answers. So say you wanted the 7th root of 20. Well, again, press math. Press the 5. 7th root of 20. So it's blinking there. Press the 7. Move forward with the arrow key of 20. Now let's say you made a mistake and you wanted the 8th root of 20. And you already have this expression. You can, of course, press enter and then enter everything again, or you can navigate using the cursor keys. And if you're on the 7 and you write 8, it'll change it. And then you can navigate back to next to a 20 if you want. Anyways, we did want the 7th root of 20, so let me go back. Change the 8 to a 7 again, there. And then if I press enter, again, here's an irrational answer because the 7th root of 20 is not a perfect root, so we get an irrational number. 1.534127405. Now the calculator cannot display an infinite number of decimals, so it stops here. So this is of course an approximation to this answer. This is the perfect expression, and this is an approximate representation of this. Now another very common key you're going to have to use on the TI for the ACT and many other tests is of course the pi value. Now we know that pi is approximately equal to 3.1415, etc. But you know, it's better if we use the pi symbol, which will use as many significant digits as we've set it to on the calculator. So you can see that pi doesn't appear anywhere on the keys, but it is above the hat key here for the exponent. You can see that it's on the left side there, pi in blue. What does that tell you if it's in blue? That you press the second key and that hat key to get pi. Second, hat key, pi, and there's the pi symbol. If I press enter, the calculator is going to say, oh, you want to see the value of pi. There you go. Now, of course, this is an approximation. There's no way to write pi precisely except for using its symbol, because pi is an irrational number, which means it has an infinite number of decimals without a repeating block. So the answer shown here is an approximation using 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal values. And that's typically good enough for anything that we want to use on an ACT test or even in a lot of physics applications. So this is a very, very usable answer. So if you wanted to say find the circumference of a circle or the area of a circle and it involves use of pi, you now know where pi is to be found. Okay. Next, we want to go over the trig functions, sine, cosine, and tangent. ACT tests will typically have some questions involving sine, cosine, and tangent, and I'm going to go over a few tips that you may want to consider for the ACT test later on. So you may want to use the sine, cosine, and tangent keys on the calculator. So this is where, remember that mode key. It's very important that we verify that we have it set in the right mode. If we press mode, and you can see here radians and degrees. Make sure that you've set it to degrees, unless you know what you're doing and you know how to work with radians. So once that you've made sure that the calculator is set to degrees, we can use the trig functions. Very simple. Let's say you wanted to know what the sine of 45 degrees is. So you would press sine. Now it's opening a parentheses. You key in the angle, which is 45 in degrees. And you can either close a parentheses, find the answer, or you can simply, after pressing the sine and the angle 45, press enter, and you get the right answer. There's no need to close it. But let's say you wanted to know what the sine of 45 minus the sine of 20 degrees is equal to. Well, then you have to be careful. Sine of 45. If I keep going here and press minus without closing the parentheses, I'm going to get the wrong answer. So I would need to close it, minus the sine, parentheses. It automatically adds it, put in the angle, and then I can either keep it like that or close it. I'll just close it for aesthetic reasons, and there's the prompt, sine of 45 minus the sine of 20. And you got the right answer. As to the rest of the trig functions, cosine and tangent, and it's exactly the same way. So let's say we wanted to know the cosine of 50. We press cosine of 50 degrees minus the tangent of 28. So we would do close parentheses, subtract the tangent, angle again, 28 degrees. I'll close it just for aesthetic purposes. Press enter. and you got the answer. So the calculator did the cosine of 50, it did the tangent of 28, and it subtracted the second value from the first, giving us the correct answer. Finally, if you go over the tips section for the ACT, you may want to use the inverse of sine, the inverse of cosine, and the inverse of tangent. What those do is, if say, we find the sine of 60 degrees, we got the answer. What if we know the answer, but we don't know what angle it corresponds to? Well, that's what the sine -1, cosine -1, and tangent -1, or inverses of the sine, cosine, and tan functions are for. If I press second sine key, accessing that sine -1, and in the parentheses, I key in not the angle, but the answer to the sine for that angle. Again, assume that I know that this is the value of the sine for an angle, but I don't know that angle. So the sine -1 function will tell me the angle that corresponds to that answer. So if I key in 0.866,025,4038. So if I do sine -1 of this value, it should give me 60 for 60 degrees. The same thing will work for the cosine -1 and tangent -1. Again, if I know what the cosine of a given angle is equal to, but I don't know what that angle is, I can use a cosine -1 function or inverse of cosine. And the same thing for the tangent, inverse of tangent function. Something else that will be very handy when you're using the TI83 or the TI84 is this answer key. It's one of the options above the negative sign. It's in blue, A and S, so you access that by pressing the second or blue key and then that negative sign for answer. So let me show you an example. Let's say that you needed to know how much 45 times 9 is equal to. You key that in, you got the answer of 405. But suppose that the prompt was, what is 17 minus the answer of that? So 45 times 9, you know it's 405. So instead of writing 405, you can just key in the second negative sign for answer, and it's going to do 17 minus the answer. In other words, 17 minus the 405. It's the previous answer that you obtained. 17 minus 405 is negative 388. 17 minus 405 is negative 388. So it's a convenient key to use, maybe not in this case because writing or keying in 405 is not really a big deal. But let's say you were working with pi and you did something like, what is 5 times pi? And you have this huge number here with a lot of decimals, and you need to keep using all those decimals, subtracting say from 100. It's really, you really wouldn't want to copy this number. You can make mistakes, etc. So what you would want to do is just use that answer key, answer minus say 200. Let's say the prompt was along those lines. So you can again see that the answer key can be convenient. Now just be careful. If I again need to use the answer of 5 times pi, which is this one right there, if I press the answer, if I use the answer key, it's not going to be pointing to that 15.7, etc. It's going to be pointing to the previous answer. And you see that? So the answer key is always going to access the last value computed. So you just be very careful with that. Something else that's going to be important for you to know is, say you enter a complicated expression that you were asked to solve, like this one. let's say this was the expression that you were trying to figure out. Negative 25 squared, the negative is not part of the squaring, be careful, plus the fourth root of 287 plus, in parentheses, negative 5 times 8. Now, let's say that we made a mistake and that it was 288, not 287. Rather than press enter and then have to key in the whole thing again, you can, remember, scroll using the arrow keys. Put yourself on top of the 7, on the 7, and then if I press the 8, it's going to just write over the 7. And now I have my correct expression. But what if I really needed to write not 288, but say 1, 5 for 15? Well, you move, you delete that extra digit that you have, so you press del, and then you write over the 28, so you stand on the 2, 1 moves forward to the 8, 5, so now it's the 15. Now, another very important key is this insert key right there. Above the del, in blue, is INS for insert. Let's say that I forgot that between the first and the second term here, I was supposed to subtract 5 first and then add the fourth root. Well, I can put myself here on the plus sign on the add. Second, del for insert. Notice how the cursor changed. It's now an underscore. So it's ready to start writing without eliminating what's on there. So again, let's say that I was supposed to subtract first, I don't know, 25 from that, and then add. Because I use the insert key before writing the subtract 25, it actually inserted those digits. Now, as soon as I move with the arrow keys, the insert function is going to stop working, and you can see that because the cursor will change. You see? Now it's changed. So if I start writing, say, here on the add sign, it's no longer in insert mode, so it'll write over it. For example, if I press the multiplication, you see how it's no longer inserting it, but just writing over it. This was the original expression. Okay, so if I press times, it'll write over it. If I forgot that I was supposed to multiply the fourth root of 15 by a certain number, say 3, then I would need to again use that second del for insert. Notice how the cursor changes. So that means it's ready to start inserting whatever I write on the spot, times, I don't know, 3, whatever, and then the rest of the expression will continue as is, plus that parentheses negative 5 times 8. And remember, as soon as you move with the arrow keys, it breaks the spell. It'll stop inserting. You see how the cursor changed? You see? And that would be the answer for that terrible looking expression. Another thing that's important to know how to use on the TI83 and TI84 is that scientific notation format. You will get on the ACT from time to time questions that involve the use of scientific notation. So how do you work with that? Well, let's say that this number is 1.7 E4, which means 1.7 times 10 to the fourth power. 1.7 times 10 to the fourth power. Well, on the TI83, TI84, on the comma key above, there's that EE. That's the E in scientific notation. So if we press 1.7 second comma for the EE, now it's showing an E to the fourth power. So this is 1.7 times 10 to the fourth power. That's what the E stands for. And because I have it set to float, you can see that 1.7 E4, which means 1.7 times 10 to the fourth power in scientific notation, is equal to 17,000 in normal format, normal number format. the way scientific notation works is that this 4 is telling you how many times you would move this decimal point forward because it's positive. So if you're at the 1.7 between the 1 and the 7, and you move that decimal point forward 4 times, 1, 2, 3, 4, you end up with a number 17,000. Finally, on the ACT exam, you may encounter some imaginary number type problems, expressions that involve the use of I for imaginary. Now, the object of this specific video is not to teach you about imaginary numbers, so we're assuming that you know how to work with them. So say that you had to do 2 plus 3i, so you would do 2 plus 3, and if you're wondering where the I for imaginary number is located, it's right above that decimal point in blue. There's the I. So that means use the second key. Pressing the decimal point will access that I. And you can see now in the calculator how it's displaying the 2 plus 3i. So that's the imaginary number, 2 plus 3i. And let's say that you needed to add to that plus 5 minus 6i. So in parentheses, we would simply do 5 minus 6, and then that I, close the parentheses, so it's 2 plus 3i plus the 5 minus 6i in parentheses. And what the TI will do is it'll actually add the real parts, the 2 and the 5, which is 7, and then work with the imaginary parts, the plus 3i at a subtracting 6i, so it's 3i minus 6i, which ends up being a minus 3i, and that's why this is the answer it gives you. Now you can also multiply with imaginary numbers in a similar format. Let's say you needed to know what 5i, so 5i times parentheses, let's do negative 4 plus 8i. Okay, so let's say that you needed to come up with this expression, 5i times, and then negative 4 plus 8i. Now remember that this times, we really didn't have to use it. We could have just left the expression as 5i parentheses, because the calculator knows that when you have two things next to each other without a mathematical operation between them, it automatically means multiply. I'll prove that to you in a second. But this expression at the end of the day is 5i times this imaginary number, negative 4 plus 8i. Press enter, and it'll give you the answer in imaginary format. Now, I want to prove to you that you could have simply entered 5i, parentheses, negative 4 plus 8i, and it should give us the exact same answer. Now, without getting too technical, I'm just going to quickly remind you how to graph, if you know how to use the graphing function on the TI8384. It's really very simple. On the top part right here, you have a series of keys. The main keys that you want to use, graph here, y equals. So when you're in the regular screen where you enter your regular operations and things like that, if you press y equals, it'll take you to an area of the calculator when you can actually enter equations for lines or for anything, quadratics or trig functions or anything. In this case, the first line, this is a color of plus CE TI84, so it allows you to actually graph in color, etc. But that's just, you know, it's not something that really matters. At the end of the day, on any of the TIs, you can graph several lines at once. The first one here is 5x plus 3. The second line, which it will simultaneously graph, is negative 2x plus 1. So when I press graph, it's actually going to do the first one first, and then the second one on that same graph. The first one is the one in blue, and the second one is in red. So entering your equation here is very simple. I'll clear it so you can see how. 5x plus 3, 5, use this x key right here, x plus 3. And then if you wanted to say enter that second one, negative 2x plus 1, let me erase it, negative 2x plus 1. Yes? Now that you have the two equations that you want to work with, then you can just press graph and see the corresponding lines for those two linear equations. Here's the first one, 5x plus 3. You can see that it's crossing at plus 3. and then the negative 2x plus 1. It's crossing the y-axis at the positive 1 spot, which matches with what we did. The first one has a positive slope, the second one has a negative slope. You can also zoom, you can also trace, which will follow the line, one of the lines, and it'll give you the x and the y value. This can be useful, but you really need to know what it is that you're doing there, and then you have to be careful and make sure that the way that you've set up your graph is correctly specified, so that you get even numbers or integers rather than numbers with a lot of decimals on them. That's due to the scale and to the parameters that we define. So that's the trace. The window here, this is where you specify the x min and the x max values, what the scale is, y min, y max. So this is really not something you typically want to have. An x min of such a number with so many decimals, you typically want to have just integers. So let's say that I go from -5 to +5 on the x, and then a scale of 1, and then the y min, -10 and 10 is fine. And if I go to graph, what you can see here is a -1, -2, -3, -4, -5, and then +1, +2, +3, +4, and +5 for the x-axis. We kept the same scale for the y. So if we press trace, we're on the blue line, and we can move and see more values. But again, if you don't really know how to operate this trace function, matching it with a window and with a zoom, you may not end up getting the right numbers here that you may be looking for. But this will basically show you how to graph. You can zoom in, you can zoom out. There's a lot of other things that you can do with this TI83 or TI84, but again, just the basic graphing functionality. Enter the equations here in terms of x. You want to use this key for the x. Here you can see the graph, and here in the window you get to specify which x min, x max values you want with what scale. Typically you set that to 1, and then what y min, what y max values you want to set, and then its scale as well.